Welcome to Lecture 7 of Computer Programming Fundamentals, L7 Structured Programming in C. The development of reliable computer programs hinges on the adherence to structured programming best practices. Structured programming best practices independent of any specific computer programming language. As such, it is not the specific computer programming language deployed that ensures the development of reliable computer program code, but rather the adherence to these structured programming best practices. Therefore, once knowledge of structured programming best practices is achieved, given the C computer programming language, that knowledge can be applied universally to all computer programming languages, including the Java computer programming language, which we will see later in this course, as we transition from the computer programming language procedure-oriented paradigm to the computer programming language object-oriented paradigm. Getting back to the adherence to structured programming best practices requires that all computer programming logic routines are confined to three principal families of control structures, namely sequence, repetition, and decision. Lecture 7 will demonstrate these families of control structures in some detail, given the use of computer program code models that demonstrate each control structure. The three families of control structures which provide the underpinnings for structured programming best practices can further be subdivided. The sequence family contains only one control structure, whereas the repetition and the decision families can be further subdivided. The repetition family includes three individual control structures, namely the for, the do-while, and while individual control structures. The decision family includes two individual control structures, namely the if and the switch individual control structures. Each of these individual control structures is independent of any specific computer programming language. Thus, they can be applied universally to all computer programming languages, even across all computer programming language paradigms. So let's demonstrate them using the C computer programming language, the computer programming language that pioneered structured programming best practices. Structured programming best practices required in today's dominant computer programming languages, essential for producing reliable computer program code. Computer Program Code Model L7A demonstrates the sequence control structure. The sequence control structure is typical of the main function definition computer program code, where computer program instructions are executed in sequence. Here note the location of the computer program declaration instructions. Declaration of the data variables local in scope and age to the main function definition, namely int num semicolon char last name left bracket 80 right bracket semicolon. These computer program instructions must be placed in the sequence before the printf and scanf function calls that use these data variables as arguments. Getting back to the sequence of computer program instruction execution, note the computer instructions printf left paren double quote please enter integer \n double quote right paren semicolon. Scanf left paren double quote %d double quote comma ampersand num right paren semicolon. Here the printf function call must precede the scanf function call. Naturally, the prompt for user data entry must precede the user data entry of the integer 35. Likewise, the same sequence control structure adherence applies for the computer program instruction code pair printf left paren double quote please enter last name \n double quote right paren semicolon scanf, left paren, double quote, %s, double quote, comma, last name, right paren, semicolon. Here again, the printf function call proceeds the scanf function call to allow the last name prompt before kubli is entered by the user. Finally, complying with the input processing output model, the computer program instruction printf left paren, double quote, num is %d, comma, last name is %s, /n, double quote, comma, num, comma, last name, right paren, semicolon, outputs the final result in the proper control structure sequence. In closing, note the braces which also comply with the sequence control structure, where the left brace indicates the start of the sequence and the right brace indicates the end of the sequence. Computer Program Code Model L7B demonstrates the for-loop control structure. The for loop is a member of the repetition family of control structures. The for loop is used when the number of repetitions is predetermined. Predetermined or fixed before the execution of the computer program code. Okay, let's take a look at the structure of the for loop control structure, namely for left paren, mynum equal 1 semicolon, mynum less or equal to 6 semicolon, mynum plus plus, right paren. Left brace, square equal mynum asterisk mynum semicolon. Printf left paren, double quote, square of %d equal %d /n double quote, comma, mynum, comma, square, right paren, semicolon, right brace. First, the for loop header part. For left paren, mynum equal 1 semicolon, mynum less or equal to 6 semicolon, mynum plus plus, right paren. This reminds me of function definition header that we discussed in Lecture 6C Basics. Note the for loop header sets the stage for the repetition code that follows. That's sandwiched between the braces. Within the parentheses of the for loop header we see 3 computer program assignment instructions, namely mynum equal 1 semicolon, mynum less or equal to 6 semicolon, mynum plus plus. Of these 3, the first, mynum equal 1, assigns or initializes the data variable mynum with a value of 1 before the for loop begins. In other words, mynum is set to 1 before any of the repetitive computer program instructions execute. Those computer program instructions between the left and right brace. The second of the 3 instructions included within the for loop header, namely mynum less or equal to 6, sets the limit for the fixed or predetermined number of repetitions. In this case, 6 repetitions will take place because mynum starts off as 1 and terminates when mynum is less than or equal to 6, which leads us to the third of the 3 computer program instructions included within the for loop control structure header, namely mynum plus plus. The plus plus operator after the data variable mynum provides an example of a post-unary increment operator, which increments the data variable mynum by 1 after one execution of the repetitive computer program instructions. Thus, in this case, after one repetition, the value of mynum will be set to 2. So before we take a look at the repetition part, let's summarize the for loop control structure header. In this case, it provides 3 functions to control the number of repetitions. Sets the start value to begin the number of repetitions, sets the limit to end the number of repetitions, increments the data variable controlling each repetition. Now let's look at the repetitive computer program instruction part, namely left brace, square equal minum, asterisk minum, semicolon, printf, left paren, double quote, square up %d equal %d, backward slash n, double quote, comma, minum, comma, square, right paren, semicolon, right brace. The first computer program instruction, square equal minum, asterisk minum, semicolon, assigns the square of minum to the data variable square. The second computer program instruction, printf, double quote, square of %d equal %d backward slash n, double quote, comma, minum, comma, square, right paren, semicolon, is your basic printf function call that displays the result of each repetition to the console. Note for the first repetition, the value of the square is 1. And with the last repetition, the value of square is 36. One last point to examine, namely computer program instruction int minum, comma, square, semicolon. Here data variables local in scope and age to the main function definition are declared prior to their use in the for loop, which is also included in the main function definition. Take a look at the placements of the braces that demarcate the main function code, with the braces that demarcate the for loop repetitive computer program instructions. Note here the indentation to improve computer program readability, as well as ensuring the balance of right and left braces. In conclusion, I trust that computer program code model L7B demonstrates the advantage of the for loop control structure over the sequence control structure, particularly when the execution of predetermined repetitive logic is a crucial part of the computer program, a crucial part of the computer program that demonstrates the structured programming best practice, a structured programming best practice for supporting repetitive predetermined logic. Computer program code model L7C demonstrates the do-while loop control structure. The do-while loop is a member of the repetition family of control structures. The do-while loop is used when at least one repetition will be performed. Okay, let's take a look at the structure of the do-while loop control structure, namely do, left brace, printf, left paren, double quote, this is the %d iteration backward slash n, double quote, comma, I, right paren, semicolon. I equal I plus 1, semicolon, right brace, while, left paren, I less than or equal to 3, right paren, semicolon. First, the do-while loop header part. Just do. Note the do-while header sets the stage for the repetition code that follows. That's sandwiched between the braces. Thus, the keyword do starts the execution of the repetition computer program instructions, those between the braces. Nothing more, as in this case, there are no computer program instructions included with the do keyword to control the number of repetitions. As such, for the do-while loop control structure, at least one repetition will be performed. Next, let's look at what terminates the do-while loop, namely while, left paren, I, less than equal 3, right paren, semicolon. This is a computer program instruction that contains the while part. Note the semicolon terminating in while computer program instruction. This computer program instruction reminds me of a function call where I, less than or equal to 3, is an argument passed with the call. In this case, computer program control will be returned to the do header, while data variable I is less than or equal to 3. So the while part sets the limit for the number of repetitions performed. Next, let's take a look at the repetition computer program instruction part, the part between the left and right braces. namely left brace, printf, left paren, double quote, this is the %d iteration backwards /n, double quote, comma I, right paren, semicolon, I equal I plus 1, semicolon, right brace. The first computer program instruction here, printf, left paren, double quote, this is the %d iteration backwards /n, double quote, comma, I, right paren, semicolon, is your basic printf function call that displays the result of each repetition to the console. Note for the first repetition, the value of data variable I is 1. No surprise, as with the do-while control structure, at least one repetition will be performed because the do-while loop termination decision comes after at least one repetition. In this case, when data variable I is less than or equal to 3. Well, so far we have discussed the beginning and end part of the do-while loop control structure. Take a look at the second repetitive computer program instruction, I equal I plus 1, semicolon. Here the data variable I is incremented. In other words, in this case, the incrementing is performed as part of the repetitive computer program instructions part. One last point to examine, namely computer program instruction I equal 1, semicolon. Here data variable I is local in scope and age to the main function definition, is declared prior to its use in the do-while loop, which is also included within the main function definition. Take a look at the placement of braces that demarcate the main function code. With the braces that demarcate the do-while loop repetitive computer program instructions, note here the indentation to improve computer program readability, as well as ensuring the balance of right and left braces throughout the entire computer program. In conclusion, I trust that computer program code model L7C demonstrates the differences between the do-while loop control structure and the for loop control structure. Computer program code model L7D demonstrates the while loop control structure. The while loop is a member of the repetition family of control structures. Okay, let's take a look at the structure of the while loop control structure, namely while left paren, minum, explanation point equal 0, right paren. Left brace, square equals minum, asterisk, minum, semicolon. Printf, left paren, double quote, square of %d equal %d backwards /n, double quote, comma, minum, comma, square, right paren, semicolon. Printf, left paren, double quote, enter a number, left paren, 0, to quit, right paren, backwards /n, double quote, right paren, semicolon, scanf, left paren, double quote, %d, double quote, comma, ampersand, minus, right paren, semicolon, right brace. First, the while loop header part. While, left paren, minum, explanation point equal 0, right paren. Here the termination decision of the while loop is made if the data variable minum is not 0. At least one repetition will be performed. One repetition of the computer program instructions included between the braces. So in the case of the while loop, the decision to perform the repetition is made at the beginning, whereas with the do while, the decision to perform the repetition computer instructions is at the end. Therefore, depending on the value of the data variable minum, there could be no repetitions. For example, if minum starts off as 0, whereas for the do while loop, there is always at least one repetition performed, because the decision point for the do while comes after the repetitive computer instructions. whereas for the while loop control structure, the decision point computer program instruction is included as part of the while loop header. A computer program instruction using the comparison operator explanation point equal or not equal included before the execution of the repetitive computer instructions. Okay, next let's analyze the repetition computer program instructions part, namely left brace, square equal mynum asterisk mynum semicolon, printf left paren, double quote, square of %d equal %d backward slash n, double quote, comma, mynum, comma, square, right paren, semicolon. Printf, left paren, double quote, enter a number, left paren, 0 to quit, right paren, backward slash n, double quote, right paren, semicolon. Scanf, left paren, double quote, %d, double quote, semicolon, ampersand, mynum, right paren, semicolon, right brace. Here the first repetitive computer program instruction, square, equal mynum asterisk mynum, semicolon, is a computer program assignment instruction that assigns the square of the data variable mynum to the data variable square. Next, the second computer program instruction here, printf, left paren, double quote, square of %d equal %d backward slash n, double quote, comma, mynum, comma, square, right paren, semicolon, is your basic printf function call that displays the results of data variable square to the console. The next two computer program instructions, printf, left paren, double quote, enter a number, left paren, 0 to quit, right paren, backward slash n, double quote, right paren, semicolon, scanf, left paren, double quote, %d, double quote, comma, ampersand, mynum, right paren, semicolon, are actually used to control a number of repetitions performed by the while loop control structure. A number of repetitions completely under control of the user. Given this combination of printf and scanf function calls, computer program instruction function calls that first prompts the user and then accepts data input from the user. For example, if the user does not enter a 0, another repetition of the while loop is performed, where the value of the data variable mynum entered by the user is squared. As such, in this case, the number squared and the number of while loop repetitions is completely determined by the user. Okay, given that for the while loop, the decision point is before the repetitive computer program instructions, one might ask, how do we handle the first time initialization for the data variable mynum? To answer this question, take a look at the computer program instructions. Those instructions included outside the while loop control structure, but within the main function definition. Namely, int quit, comma, mynum, comma, square, semicolon, printf, left paren, double quote, enter a number, backward slash n, double quote, right paren, semicolon, scanf, left paren, double quote, %d, double quote, comma, ampersand, mynum, right paren, semicolon. The first computer program instruction, int quit, comma, mynum, comma, square, semicolon. Here the data variables quit, mynum, and square are declared as integers. These data variables are local in scope and age to the main function definition. As such, since the while loop control structure is within main, these data variables scope and age range applies also to the while loop control structure. The next two computer program instructions, printf, semicolon, double quote, enter a number, backward slash n, double quote, right paren, semicolon, scanf, left paren, double quote, %d, double quote, comma, ampersand, mynum, right paren, semicolon, provide the same prompt and data entry option for the user, but this first time user data entry option does not prompt for the value of 0. so there will be at least one repetition of the while loop control structure. Note from the console display I entered 20 for the value of MyNown twice. Note the difference in prompts for each user data entry. The data input value of 0 was not an option the first time. In conclusion, the while loop control structure header includes the repetition decision point computer program instruction, whereas the do while control structure does not. However, both repetitive control structures can be used when the number of repetitions is not predetermined, but is completely under user control, because the loop termination computer instructions are outside the do while and while loop control structures, which, as we have seen, is not the case for the for loop control structure, a repetitive control structure where the loop termination computer program instruction is part of the for loop control structure header. I trust, given the discussion of these three members of the repetitive family of control structures, has pointed out the structured programming best practice for each. Computer Program Code Model, L7E, demonstrates the if-else decision control structure. The if-else is a member of the decision family of control structures. The major feature of this member of the family of decision control structures is that for the if-else decision control structure, only two choices for the decision making are presented. Given these two choices presented, only one decision path can be taken. Or in other words, if the condition is met, the choice or path is taken. Else, if the condition is not met, the other choice of the two presented is taken. Okay, let's take a look at the if-else decision control structure. If left paren I equal 0, right paren. Left brace, printf, left paren, double quote, I is equal to 0, \n, double quote, right paren, semicolon, right brace. Else, left brace, printf, left paren, double quote, I is not equal to 0, \n, double quote, right paren, semicolon, right brace. Here the if part, namely if left paren I equal 0, right paren, left brace, printf, left paren, double quote, I is equal to 0, \n, double quote, right paren, semicolon, right brace, is the part where the condition is tested, that within the parentheses after the if keyword, where the equality operator equal tests the data variable I for equality to 0. If the condition test is satisfied, the computer program instructions, those between the braces following the if header, are executed. Namely, in this case, the single instruction, printf, left paren, double quote, I is equal to 0, \n, double quote, right paren, semicolon, which displays I is equal to 0 on the console. Note my first execution of the computer program model, L7E. Next, let's look at the else part of the if-else decision control structure, namely, else keyword, left brace, printf, left paren, double quote, I is not equal to 0, \n, double quote, right paren, semicolon, right brace. Here the else part of the if-else decision control structure is executed if the condition expression in the if part is not satisfied. In this case, if I is not equal to 0. The code between the braces following the keyword else, namely printf, left paren, double quote, I is not equal to 0, \n, double quote, right paren, semicolon, displays I is not equal to 0 on the console. Note the second execution of computer program code model L7E that verifies this case of the if condition failing. Okay, now that the if-else decision control structure has been discussed, let's talk about its location within the overall computer program code. Note the control structure is included within the main function definition. following the computer program declaration instruction for data variable I, and following the printf and scanf function call computer program instructions. The combination of computer program instructions that provided the data entry value for the data variable I evaluated by the if part of the if-else decision control structure. This allowed me to execute L7E twice, the first time for data variable I equal to 0, the second time for data variable I not equal to 0. Actually, the value of 67 was entered for this case. The second execution then displays on the console, proving both cases of I equal to 0 followed by I not equal to 0. I trust L7E demonstrates the if-else decision control structure, the member of the decision family of control structures demonstrating the structured programming best practice for decision making when there are just two choices presented. Computer Program Code Model, L7F, demonstrates the switch decision control structure. The switch is a member of the decision family of control structures. The major feature of this member of the family of decision control structures is that for the switch decision control structure, multiple choices for the decision making are presented. Given these multiple choices presented, multiple decision paths are available. The specific path taken will be determined by the specific choice selected from the multiple choices presented. As such, the switch control structure is used for situations where a single choice is made from a multiple number of choice options, like a user selecting an item from a menu of multiple items. Many of today's computer programming languages refer to this control structure as the do-case control structure. Okay, let's take a look at the switch decision control structure. Switch, left paren, my number, right paren. Left brace, case 1 colon, printf, left paren, double quote, you chose number 1, double quote, right paren, semicolon, break, semicolon, case 2 colon, printf, left paren, double quote, you chose number 2, double quote, right paren, semicolon, break, semicolon, case 3 colon, printf, left paren, double quote, you chose number 3, double quote, right paren, semicolon, break, semicolon, default, colon, printf, left paren, double quote, invalid number, double quote, right paren, semicolon, break, semicolon, right brace. The key part of the switch control structure is the header, namely, switch left paren, my number, right paren, where switch is the keyword that identifies this as a switch control structure, and where my number included between the parentheses is a data variable depending on its value that points to a specific case subheader keyword. In this case, if my number is equal to 1, the switch control structure header will transfer computer program control to the case subheader label case 1 colon. Okay, now that we know how the cases are selected, let's take a look at the case selections available part. Specifically, the computer program instructions block, the computer program instructions demarcated by the left and right braces, namely left brace, case 1 colon, printf, left paren, double quote, you chose number 1, double quote, right paren, semicolon, break, semicolon, case 2 colon, printf, left paren, double quote, you chose number 2, double quote, right paren, semicolon, break, semicolon, case 3 colon, printf, left paren, double quote, you chose number 3, double quote, right paren, semicolon, break, semicolon, default, colon, printf, left paren, double quote, invalid number, double quote, right paren, semicolon, break, semicolon, right brace. Here the case 1, 2, 3, and default subheaders are considered computer program labels. For example, note the colon syntax for terminating each subheader. Each label receives computer program control from the switch control structure header based on the value of the data variable MyNumber. The case subheaders are identified by the case keyword. Let's take a closer look at the case subheader label, namely case 1 colon. Here case is the keyword identifying this as a case subheader. The literal data variable 1 indicates that this is the case for data variable MyNumber equal to 1. The terminating colon indicates that this statement is a computer program label. Thus, this is how the case subheader label is selected. Next, once the case subheader label is selected, the computer program instructions following the case subheader are executed. For case 1, namely, printf, left paren, double quote, you chose number 1, double quote, right paren, semicolon, break, semicolon. The first computer program instruction is your typical printf function call, where you chose number 1 is displayed on the console. The second computer instruction, break, forces computer program control to exit the case subheader computer program instruction block. For cases 2 and 3, the same computer program logic prevails. Which brings me to the default case. Since the choices or decision paths taken are mutually exclusive and collectively exhausted, structured programming best practices for the switch control structure require a default case to process any specific choice not taken. As such, if the value of data variable MyNumber is anything but a 1, 2, or 3, the default case path is taken. Note the command processor where I ran the computer program 4 times, once for each possible path of mutually exclusive and collectively exhausted choices. Okay, now that the switch control structure has been thoroughly discussed, let's review it in context of the entire computer program L7F. Note the computer programming instructions included in the main function definition, but before the switch control structure, namely int MyNumber, semicolon, printf, left paren, double quote, please enter a number, colon, /n, double quote, right paren, semicolon, scanf, left paren, double quote, %d, double quote, comma, ampersand, MyNumber, right paren, semicolon. The first computer program instruction here, int MyNumber, semicolon, declares the data variable MyNumber as an integer. The second pair of computer program instructions, namely printf, left paren, double quote, please enter a number, colon, /n, double quote, right paren, semicolon, scanf, left paren, double quote, %d, double quote, comma, ampersand, MyNumber, right paren, semicolon, as we have seen before, allow the user to control the value of MyNumber. For each execution of the computer program, note I executed it 4 times to prove each of the 4 cases. In conclusion, I trust the switch control structure demonstrates decision control. Decision control when there are multiple choices with only one choice or decision path to take.